This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on U substitution with definite integrals. So we have the integral from 0 to 1 of x times quantity x squared plus 4 to the third power dx. These endpoints, the integral from 0 to 1, makes this a definite integral. So our strategy is to find the antiderivative, plug in the endpoints, and subtract. That's in essence what we're trying to do here. However, I'm going to do something slightly different than is usually done. I'm going to go ahead and change the endpoints with the U substitution. So you'll recognize that x squared plus 4 is in parentheses, and the derivative of that is 2x, which is a multiple of x. So the u that we're going to use is going to be u equals x squared plus 4. And we're going to go ahead and try to evaluate that antiderivative. So the derivative with respect to x of u is the derivative with respect to x of x squared plus 4. The derivative with respect to x of u is du dx. And the derivative with respect to x of x squared plus 4 is 2x. I prefer to solve for dx, so if that's the case, du would be 2x dx, and du divided by 2x would be dx. So dx will be replaced with du divided by 2x. X squared plus 4 will be replaced with u, and then we'll have to think about how we're going to work with those endpoints. But these endpoints are x's, so this is x is 0 and x is 1. So x ranges from 0 to 1 of x times x squared plus 4 to the third. Now you'll notice u is x squared plus 4, so I could convert these x's to u's if that's something I would like to do. So again, when x is 0, what would u be? U would be x squared plus 4, u would be 0 squared plus 4, or 4. So this x equals 0 could be converted into u equals 4. Now when x equals 1, what is the value of u? U again is x squared plus 4. So u is 1 squared plus 4. 1 plus 4, u is 5. So we have here is x from 0 to 1 could be the same thing as u goes from 4 to 5. Now we've got to make some changes here. X squared plus 4 is u. Dx is du over 2x, so we kept those from the previous page. Notice there was all of our computation on the previous page that we used to get there. So u goes from 4 to 5, x, u to the third, du divided by 2x. Notice the endpoints change to u's. That's the preferred strategy. If you're going to do a u substitution, I prefer to change the endpoints in the middle of the problem. X is still x. X squared plus 4 is u to the third power, and dx is replaced with du over 2x. For this strategy to work, all of the x's must divide out, and you notice they do. X divided by x goes away. This 2 that I have downstairs is really 1/2, so we could pull the 1/2 out in front. And I'd be left with 1/2 integral from u goes from 4 to 5 of u cubed du. And again, we're very happy all of the x's are gone. No x's in the argument. It's du and no x's in the endpoints. So we can just go ahead and finish the problem. The antiderivative of u to the third is u to the fourth over 4. And then we would plug in the endpoints and subtract. Now, how is that going to look? 1/2 times 1/4 is 1/8. U to the fourth as u goes from 4 to 5. So plugging in the endpoints, 1/8, 5 to the fourth, minus 1/8, 4 to the fourth, or 1/8, 5 to the fourth, minus 4 to the fourth. Pull out a calculator, 1/8, 625 minus 256. We get an answer of 369 divided by 8 when we go ahead and do that. So U substitution is challenging, and with the definite integrals, with the endpoints, my suggestion is that you change the endpoints as soon as you substitute in the value for u. Let's look at our next example. We have the integral from 0 to 2 of 5x over x squared plus 9 dx. This, of course, means x goes from 0 to 2. Looking at this, we have to decide what is going to be u. And the answer is the denominator. U will equal x squared plus 9. Because the derivative of x squared plus 9 is 2x is some multiple of what's left. That will enable all of the x's to divide out. So saying that, we need to take the derivative of u with respect to x will be 2x. Derivative with respect to x of u is the derivative with respect to x of x squared plus 9. Du dx is 2x. My preferred approach is to solve for dx. So du is 2x dx. Du divided by 2x will equal dx. So dx becomes du over 2x. X squared plus 9 becomes u, and then 5x upstairs is left alone. And then we've got to think about how we are going to handle these endpoints. That's x equals 0, that's x equals 2. But I want to change from a world of x's to a world of u's. So I will plug the 0 into this equation, 0 squared plus 9. I'll plug the 2 into this equation, 2 squared plus 9. Again, emphasizing that that's x equals 0, x equals 2. So plugging the 0 into 0 squared plus 9, I get u is 0 squared plus 9. When x is 0, u is 0 squared plus 9. When x is 2, u is 2 squared plus 9. 5x is still 5x. X squared plus 9 is u, and dx is du over 2x. The good news here is the x's divide out. So we have 5 halves can come out in front. All that's left is 1 over u du. And then what does u range from? 0 squared plus 9 is 9. 2 squared is 4. 4 plus 9 is 13. So you'll notice what we have. And then the 5 halves coming out in front. We will have 5 halves times the integral from 9 to 13 of 1 over u du. And let's recall the integral of 1 over u. Integral of 1 over u is natural log of the absolute value of u, although the u's are positive, so you don't really need to worry about the absolute value here. But I've got it there anyway. So 5 halves natural log u as u ranges from 9 to 13. So we plug those in and subtract. So 5 halves is factored out. Natural log 13 minus natural log 9 would be the results of that question. And let's take a look at another one. We have the integral as x ranges from 0 to 2 of e to the 5x dx. So there's not much choice here for the u. U is going to equal 5x. Now, if u equals 5x, these endpoints are going to have to change. So let's go through the process. U is 5x, so the derivative with respect to x of u is the derivative with respect to x of 5x. So du dx is 5. Of course, the derivative of 5x is 5. I like to solve for dx. If I'm going to do that, du is 5 dx. Du divided by 5 will be dx. And now we're ready to go ahead and substitute. So e to the 5x will become e to the u. Dx will become du divided by 5. X ranging from 0 to 2 will also have to change. Again, emphasizing that fact, so I'm actually writing that in on the endpoints of the integral, x equals 0 to x equals 2. If x equals 0, u is 5x. So u is 5 times 0, u is 0. So if x is 0, u is also 0. But if x is 2, u is 5x, so u is 5 times 2, u is 10. So my next integral will be the integral as u goes from 0 to 10. Of all of this being e to the 5x e to the u, dx is du divided by 5. So there's just the relevant information I need. Making the substitution. U goes from 0 to 10, integral of e to the u du. This 5 in the denominator can be thought of as a 1/5. So let's pull that 1/5 in front of the integral sign. And what we're going to get is 1/5. The integral is u goes from 0 to 10 of e to the u du. Now what you have to remember is the derivative of e to the x is e to the x. So the integral of e to the x would be e to the x, or the antiderivative of e to the x would be e to the x. So you've got 1/5 times the integral as u goes from 0 to 10 of e to the u. The antiderivative of that will just be e to the u, and we'll evaluate it as u ranges from 0 to 10. So we have 1/5 times e to the u as u ranges from 0 to 10. Plug in the endpoints and subtract. 1/5 e to the 10th minus 1/5 e to the 0, or factoring it out, 1/5 e to the 10th minus e to the 0. And of course, what is e to the 0? E to the 0 is just 1. So we get 1/5 e to the 10 minus 1. And that will conclude this lesson.